主角下礼拜那个 demo 要几个 room，把大家挤在这边，这比较小，不要借2间，监控啊，会很多人哦，就反正就是不要挤在一起，会有点挤哦，会有点挤哦，因为它不是这样分开做，来它挤在一起可以 demo 给你看，可能一组要站3排哦，对啊，会站到3，对啊，你可是下一组就3排在一起，对啊，中间空了一下，1间是没关系，你不要太挤，真的会很多，因为不会说下一组又在外面等，下一组会在这里，所以你可能要空一下。嗯，先再注意，可以的，但是你只要把时间错开就好了。Okay, so today is January 6th, so and next week, okay, you need to come here and for each group and present your project. Okay, use your PPT and the demo video. And week 19th, that's January 20th, I will teach YOLO V4. Okay, so next week you need to present your project. And 20th again, 20th, I will talk about YOLO V4. Not here, I will because I mean everybody will be use the internet. So that's for next week, and in one more week, I'll teach you YOLO V4. So today we will talk about the faster RCNN, and the important one is the region proposal network. For the first RCNN, the important one is the region proposal network. What's a proposal? The proposal region, so it's a bounding box. Okay, and those people are from Microsoft. That's meaning to here up to here, the backbone. So we already finished the AlexNet, VGG, and ResNet, and also talk about the GoogleNet. So the thing is year 2012, okay, the Hinton, the group, and Alex, they do this one. So after this one, people start to pay attention on the deep learning. So we have a year 2015, we have VGG, the same year 2015, we have GoogleNet. And next year, 2016, we have a ResNet. So up to here, up to ResNet, we call this backbone. Backbone is for what? For encoder. For the same. Encoder is for what? For feature extract. You extract the feature and do downsampling. And from so up to here, finally we find out 5 blocks. 5 blocks as a best result. So we have 5 downsampling. So 5 blocks. Because you do downsampling. So final output usually is like the image size we call map. It's either 14 by 14 or 7 by 7. But in current situation, 7 by 7 image size or map size is too small. So right now, usually is a 14 by 14. The result will be better. But that's because that's for the encoder. So encoder is code. So that's for what? For classification. So backbone is not only for the feature extraction, they also can apply to the classification. That's meaning what? Meaning your input cannot be the entire image, contain many objects. That's not good. Your input can has only, suppose I want to classify some classify some object. You should crop the object. For input, just the object, you crop. And after encoder, after feature extraction, you try to classify this object belong to which class. Okay, so this one, encoder or backbone is for classification. So you cannot input one image has many classes or many people there, for example, because they cannot do the detection. They only do classification. So for computer vision, we talk about image preprocessing. We talk about detection, tracking, recognition, 3D reconstruction, and then AR. Okay, so that's my field about computer vision. So for the image preprocessing and doing the deep learning, what's image preprocessing? One important thing is that sometimes the input is just gray value. So the gray value image, so it's only one channel. And the gray value between 0 and 255. Most of the time, we do input is color image, so it's RGB. And each channel is the gray value 0 to 255. And right now, we have a test. So we have two channels to input. One is RGB, the other D. But usually the input for the D is 3 channel, but D is only 1 channel. So what can we do? We will do copy D. From one test image is gray value. So copy to 3 images like a D. Why? Because we want the network is the same. So one channel is for 3 RGB. The other channel, because the network will be similar. So it's not only 1 channel, it's 3 channel. But you only have a D depth. So it's D. And because finally you will want to combine together. Okay. But what's the image preprocessing for this one? It's meaning because you still will affected by the lighting. So before you input, sometimes we normalize the gray value to 0 mean and 1 standard deviation for the input. Okay, so it's not, you can, many cases, you cannot directly input the raw data. What's RAW? What's raw data? Raw data is just you got an image and input. No. Most of the time, you need to normalize the image based on the Gaussian model, 0 mean. Okay, and variance is 1 divided by variance. Sorry, divided by standard deviation. So that's meaning your normal distribution. So it's the mean and the standard variance. Okay, and there's two situations for that, for your Gaussian model. One is just for individual image. So for each image, you try to find the mean value over entire image and try to find standard deviation and do normalize by normal distribution. That's one case. The second case is based on the training data. For each pixel, you cross over all training data. You try to find the mean value and standard deviation. So each pixel of crossover all training data, you do the normal distribution. So two types. Okay, so that's pre-processing. Okay, and then the output. So in our encoder backbone case is for detection, tracking, recognition. Actually, detection is what? Detection is classification of by two types. Yes and no, face and non-face. That's for detection. Detection is one kind of classification, but only two types, two classes. One is foreground, the other background, or one is face or non-face, for example. And classification is multiple classes. Can classify to many classes. Okay, so for the encoder, it's used for classification. Okay, again, it cannot try to detect, it cannot search a region and try to find, oh, in this image, the up face is here. But it cannot. You need to crop the face and then input, crop each region and then input that it recognizes. So that's for encoder. So that's the weakness. The weakness for the encoder, for this one. So how can we improve that one? So we want to do we want to input the entire raw data and try to not only detect the location of the object, but also do the recognition or classification. So you want to do the detection, the object position, also try to classify or recognize the object. And that's what we call multitask for a detection and classification, and use faster RCNN or mask RCNN. So for the application, okay, faster and mask RCNN are more popular. 这两个应用很广啊 faster and mask. And what's R? R is region. What's the region? Region is meaning you detect the ROI, the region you interest. So it's a region, convolutional neural network, RCNN. R is region. And this one is different from RNN. RNN is recurrent. It's about temporal domain along the time. So it's temporal domain. It's a difference. And here we talk about the RCNN. Okay. So we in this two lectures today and 2 weeks later, we will talk about fast RCNN, mask RCNN, and then talk about YOLO V4. So before we talk about the YOLO V4, I will introduce you about faster, because this rely on faster RCNN and mask RCNN. And after this one, this year 2015, and we'll talk about YOLO V1. Before we talk about YOLO V4, and after we talk about faster and mask, and we'll talk about YOLO V1, V2, V3. I will introduce you for 1, 2, 3. Okay. So YOLO V1 start from year 2016. So around the same time. Okay. And YOLO V4, YOLO V1, because they publish the same year as ResNet. So they don't do anything. They just do the same thing about encoder. The difference, what should I say? The difference between this one and this one is because we want to you will input the entire image. You want to detect the object. Okay. Encoder is just for classification. For the multitask, for the FAST, you need to not only the classification, you also want to do detection. So what will you do? We will try to do the decoder. This encoder, for the FAST, we want to do is not only the encoder, we also think about we need to decode because we want to detect the object at the original image. So faster here, this one, or even not here, will include the encoder and decoder. Okay, so it's difference. And what we keep talking about. So YOLO V4, because earlier, so they don't do what? They don't have a shortcut. They don't have a identity. YOLO V2 has identity because YOLO V2 is after ResNet. So I will talk about this one later. The history, I will talk about this one later. Okay, so what I say is that YOLO V1 based on the encoder. YOLO V2 is after ResNet, so they have a shortcut, they have identity. And then Retina. Retina use feature pyramid network. Retina use feature pyramid network. So YOLO V3 is applied with Retina. So you'll find the YOLO V3 has a feature pyramid, FPN, feature pyramid network, upsampling, feature pyramid network. So after Retina, we have a YOLO V3. And after we PNet, we have a YOLO V4. Okay, so YOLO V3 is based on based on Retina. YOLO V4 is based on the PNet. Okay, so I will talk about this one step by step. And here, autoencoder actually is an encoder and decoder. So it's autoencoder. So autoencoder actually they will apply feature pyramid network. Feature pyramid network. Okay, so FPN feature pyramid network is very important. Okay. But feature pyramid network is not not invented by Retina. No, before Retina, they have just one paper talk about feature pyramid network, and Retina used work. Again, also use feature pyramid network. Okay, so we'll talk about step by step. So before we talk about faster RCNN, it's fast RCNN and then mask. Okay, so suppose you input one image. The fast RCNN is try to detect the object. Okay, and mask RCNN is try to do segmentation. Of object. So we talk about fast first. Before we talk about faster, we talk about fast. RCNN. So fast RCNN, actually history is here. In page 5, this is the history of feature detection and classification. So in the beginning, it's a RCNN. RCNN use computer vision for detection. We call selective search. They use this one for detection. And then do CNN for use AlexNet for classification. Okay, RCNN. So RCNA is not really deep learning network. They combine. Okay. And so that in the beginning, we have a RCNN region DNA. We have a S. I will talk about this one. Okay. So based on both, and I should say that probably the first one for the region CNN best. So first, improve RCN use computer vision. This is computer vision. This is not deep learning. Use the computer vision, the method called selective search for object detection. And based on you detect the object, you extract the object region. We call ROI, region of interest. We extract this region, and we do use the AXNet or VGG16 for classification. So first, RCNN and then combine computer vision and deep learning, and they can do the detection and classification. So the first paper for complete deep learning is a best RCNN. So instead of computer vision selective search, they use RPN, region proposal network, to detect the object. So RPN is for the detection, for the ROI detection. ROI is the region of interest in the object you want to detect. So they apply a faster. This one is complete. This complete deep learning network. Okay. And this one is for detection, classification, and mask. RCNN is for segmentation. Segment object. So both are different, but both are strongly relative to each other. Okay. So we talk about this one. And here I would like to mention, just repeat again, review again. Usually we do CNN convolution neural network, for example, AXNet, is fully connectional. For the FCN is fully convolutional. So here, so first RCN is a convolutional. Okay, first is also convolutional. Just try to let you know. Okay, so I do this small like a table that you understand the history. So go back to page 4. So page 4, we talk about first RCN will include the detection, include classification. However, the detection using the traditional method we call selective search. So it's not complete deep learning. Okay. We talk about page 5. We start talk about step by step. Next few pages, I will talk about the history here. So I will teach you from here to up to faster RCNN. Teach you this one. So with the related work. Okay. So starting when you think we do the research. Okay. Before this one, only encoder, right? So before this one, we have this one. Now I try to let you talk about this history because you are a graduate student. I want you think about and how to do the research. So before, in the RCNN, I'm sorry, in the first RCNN, this is the encoder, right? If I crop one region, and I can use the classification to classify this is the which one is person or is host or anything. So this is a traditional, this encoder, right? CNN and encode, and this is the MLP neural network for classification. So this is traditional method. But before people use SVM, right? Before the deep learning, you have this object and you do the SVM for classification. And right now we already proved the deep learning, the result of deep learning better than SVM. So no more SVM. Okay, so we directly use the CNN for the classification. So here you input the entire raw data. You have a different kind of object. You have a person, you have a face, you have a horse. So this one they use the traditional computer vision method we call selective search to the detect the object, detect the foreground, background. Detection only two classes are dependent: foreground and background. And then classification is based on the foreground. You try to classify it belong to the which class. Okay. So this is a RCNN. And for the encoder, this one, for the encoder here, the RCNN, they use AXNet for the classification. Okay, we already teach you this one. So what's the, I just repeat again. So AXNet have a 5 plus 3 layers. But here we talk about blocks. Okay, but I only have a 3 downsampling because at that time the GPU is not so powerful. There are only 2 and 3. So the other thing is that they use 2 GPU because that's what I say is not so powerful. So they use one network, second network, but the same. But they do 2 GPU to do the parallel processing. So the contribution for AXNet, one thing is that because they try to solve the village problems, like village problems. So they don't use sigmoid, they use Renu instead. They try to solve the village problems, so they use Renu instead of sigmoid. The second is because GPU is not so powerful, so they use 2 GPU, but they use the same network, but they have a crossover. The third one, they developed called LRN. What's LRN? LRN is kind of crossover the maps. But right now we don't no more LRN, so I ignore this one. Right now we don't this kind of the same kind of normalization. Okay. And right now we use a batch normalization, something like that. So forget this one. The contribution for the fourth one is that they do downsampling using maximum pooling. Okay, so they have 4 contribution. Okay, and overlapping pooling is kind of the straight thing. So what I say is that downsampling is 2 kind of downsampling, right? One is use maximum pooling, second use straight. Okay, so 2 kind of method for the downsampling. So this is a easy. This is my student draw this one. So easy way for the action is 5 plus 3, and for the classification, and the loss function here because it's a classification. So usually classification use what? Use cross entropy. Okay, but it's easy. And this is for the robot arm. We do the angle. So we have because this is symmetric, so it's 180 degrees, and we divide it by 8. We have 18 classes. Okay, so if you grab an object, we define it as a success. So label 1. Fail, we label to 0 for the degree, corresponding to the degree. So total has a 36 output. But this older method is a long time ago. But at that time, because deep learning is not so powerful, so we use the concept of classification. So for a degree, right, we 180 degree, and so we use a 10 degree become one class. So total we have 18 angles. 10 degree become one class, one angle, and times two classes. One is a success, you grab it. The other is a fail. So total is a 36 output here. Okay, so we improve the accent. And then at the meantime, what I said here, we have this one. And the other one is important one is SPP. So I introduce here. Because YOLO V4 use SPP. And some network use SPP. So I would like to introduce SPP. So what's SPP? SPP called spatial pyramid pooling. So we have a maximum pooling. We have a SPP in SP pooling. So what's this one? This one is because this is done all the time, right? And all the time is when we input the image size is limited if we use fully connected neural network. Our classification, if you use fully connetional network, we talk about this one. And then because the network they connect is fixed, the size is fixed. So your input image size is also fixed. That's why later on people use a fully convolutional network instead of fully connectional network. But what else? What other method can improve? That's SPP. So if you apply SPP, that's meaning your input image size can be any. Okay, so you had at the least, I should not say only 2, because right now is because that's all the one, long time, all the time. So, but all the time is like it's not so old. It's like 8 years, something like that. Okay, so SPP is what? SPP is no matter what kind of input image size is. After SPP, your output channel of dimension will be the same. So for this example, no matter what kind of image size you input, and up to here you have many maps, right? You have many maps, whatever channel. So no matter what's the image size, okay, you will divide it by the entire one. Use one maximum pooling. So your output will be 1D, 1 by 1 by crossover all maps. So one, it's one. You can divide it by 4. So we call 4 grid, GRID, grid. We call grid. So 4 grid, and each grid you do the maximum pooling, not 2 by 2. Each grid you do maximum pooling. Okay, but remember, it's only not one map. It's cross over the entire maps. So suppose your map is at 128. So this one will be spatial domain will be one output about cross over 128. This will be 4 output cross over 128, and this will 4 by 4. So your total grid has a 4 by 4 plus 2 by 2 plus 1 comes 21 dimension crossover 128 maps. Okay, so after SPP, your output spatial domain dimension will fix. So this SPP can solve fully connected connectional network problems. 所以用这个 SPP 你可以输入不管什么 size， 它输出就会固定 size。可记得这个 size 是要 cross over 整个不同的 maps， 所以这个可以解决那个 connected 的问题。好，再来，那我们继续讲啊。So we talk about this one. So we start talk about phased RCNN. So phased RCNN, the same. Okay. But right now, phased RCNN has one important one is this one. What is this one? The normalized ROI. I talk about this one. Okay. We call ROI pooling layer. This term should be careful. We call ROI pooling layer. In here, this one, RCNN is only use traditional CNN. So this one, your input should be already detect the object. So for the first one, you can input entire image. You think of, I will input original, the raw data entire image. I want to do detection, right? I want to do recognition. But here they still use the same selective search. So this is a computer vision thing. And this is classification. Okay. But this classification, they have a bounding box here. Why? Because they want to use deep learning to refine the bounding box region. Okay. I say again. I would like to tell you the history. Here, all the RCNN they use the same. They use selective search to crop the bounding box manually. No, sorry, use computer vision and do classification. So here they strongly rely on selective search. First, you think about first RCNN, they will refine this computer vision result. So their loss function will include bounding box and classification both. So we call that a multi-task. You have two loss functions. Before we only have one loss function, or you are in. But here with two loss function. So we do the bounding box. We also do the classification. Okay. So idea is here. So the same they use the transitional computer vision we call selective search. They crop this one, and they input to here. So they have two kind of input. The first input is input entire image, but they have a two encoding, they have a too many maps. So this one. And this one, you can think about this one can be ArcNet, can be VGG, because at that time VGG already have a. So here, back to here. And this one is the size of this one. So this is the features here. Feature from here. The bounding box is initial bounding box from here. Okay. So after many maps, you based on this bounding box, you crop this region. Okay. And based on this region, you do downsampling. You normalize to the same size. No matter the size of bounding box here, you do normalization in this one, the image size will fix. As I say, you can use SPP. You can fix the size here. This called ROI pooling. SPP also is kind of pooling, right? It's pooling. SPP is pooling. Spatial pyramid pooling, so that this size is fixed. This one can apply to here. So no matter your bounding box is big or small, after SPP, you can have the same size, fixed size here. So we call ROI pooling there. So this is fixed. And then we do connective convolution. Fully connective or fully convolutional. Actually, I forget. Here, fully convolutional. So here we do fully convolutional to extract a feature. And after we first one, second one, we have 1, 2, 3. And up to here, here's on the same, here's for feature extraction. But at the final layers here, we do classification or we do refinement of bounding box. So we have a two loss function. One loss function is one. We do classification. Classify whether it's a person, horse, or anything. So suppose we have 20 classes. So we have 20 classes here. We refine the bounding box. Use regression. Because we use regression, so what will we use? We will use mean square error, right? So for classification, we use cross entropy. For the regression, we use the mean square error. Okay. So here we use both. So for classification, we use log. Actually, P log P, and the P prime. P log P, and here this P is a ground truth. So it's label 1 or 0. Okay. So if you have 20 classes, if each time you have 1 and other are these 0. Okay. And for the bounding box, here we use square term. So it's the mean square error here. But actually they don't do that. They use the other method. Okay, they call smooth L1. And I will talk about this one very soon. L1. And this one, many people use this one. Even though right now, many people use this method. And we'll talk about this one method very soon. Okay, so this for regression here, and this for classification. That's fast RCNN. Use fully convolutional network. Okay. And for the fast RCNN, okay, they use ArcNet because at that time it's old, so they use ArcNet. And just for AlexNet, the first AlexNet here is a fully connectional. Later on, they use fully convolutional. So we already talked about this one. And this output difference, this output is a histogram. So what suppose here, in this case, we have a 100 classes. So for the ground truth, each time your class is only one, other are 0. So you have in this one, for the connected, each time you label is only one class is 1. Other 999 is 0. So this one. For the convolutional, your output will be 1,000 classes. So your output will be 1,000 maps. We call heap maps. This one. You have 1,000 classes. That's meaning your output will has 1,000 maps here. Okay. And based on the map, if similar this one, if belong to that class, and they have the Gaussian bigger Gaussian distribution here. Okay. Otherwise, it will be almost 0. But the other good thing for this one is that for convolution, the good thing is that you can find the position of your class here. But this position is roughly. So actually, you will know the center position of this object, but you don't know the boundary. You should know the center, because center will be peak of the Gaussian distribution. So you know the center position. There's an object here. You don't know the boundary. Exactly boundary you don't know. Okay. So this is a modified AlexNet. And later on, people keep improve the first RCN, so they use VGG instead of AlexNet. Okay, because this is for classification. So VGG is better than AlexNet. So they got a better result. Okay. And again, I said, because all the time, the GPU is not so powerful. So people use 5 downsampling. This rate 1 is downsampling. The maximum probably talked about this one before. And the output is 7 by 7. But later on, people prove actually 7 by 7 is too small. So don't use 7 by 7. Even though you downsample only 5 times. 4 times, it's okay. So people use 14 by 14 here for the classification, and the result is better. Or even though for the detection, result is better. The other thing is before people use here, okay, our classes has 1,000. So we have 1,000 classes. But later on, people said that's not good enough. You need to plus one more class. That one is belong to the background. A background doesn't mean it's really background. Background is meaning plus one class, but this class doesn't belong to the 1,000 classes. 你要通常会再加一个不是1000类里面的一个 class， 不然你会搞混，因为万一你切到的东西是不是那1000个物体，那你还是要归类成一类，不然的话你就会有问题，就你的threshold可能不好设所以记得你在做这种分类，它有时候会把 background 变成独立一类这样子。那 background 就包括真的 background 跟不是这里面的物体这样。Okay, so we take a break. I will continue to talk about the faster RCNN.